I'm Tim Ventura, and we're joined today by Klee Irwin, a well-known author, physicist, and businessman who serves as CEO and chairman of Irwin Naturals and director of the Quantum Gravity Research Organization, a nonprofit research institute he founded in 2009. Klee founded Irwin Naturals in 1994, and it rapidly grew to become an award-winning global natural supplement company with products sold in thousands of retailers, ranging from Walmart to Whole Foods. As the director of QGR, Klee manages a dedicated team of mathematicians and physicists developing emergence theory. The mission of the organization is to discover the geometric first principles unifying space, time, matter, energy, information, and consciousness. Outside of his work in physics and nutraceuticals, Klee supports students, scientists, educators, and founders in their aim to discover solutions leading to high-impact positive change. He supported a wide number of causes, including Change.org, Upworthy, Donors Choose, Moon Express, CASA Development, the X Prize, and Singularity University, where he's an associate founder. So, Klee, welcome. It is a true pleasure and honor to have you with me today, sir.
Oh, thank you so much, Tim. I've known about your podcast for a long time, and I'm honored to speak to you and your audience.
Oh, absolutely. Well, and it's, again, a true pleasure to have you with me. So we're talking about quantum gravity research along with some of the core ideas and implications of emergence theory. This is a big, bold, and brilliant model. So I want to start out by asking, is there a high-level conceptual overview of this, like kind of something like an elevator pitch that you might use to introduce this to people?
Sure. We changed the name recently to cycle clock theory because it's more explanatory, whereas emergence is such a generalized concept. Now, emergence is very, very much part of cycle clock theory. And so let me give you the 50,000 foot kind of elevator pitch overview. So let's say you were asking yourself, what is reality, right? That's our most popular video on YouTube. What is reality, right? You can find that. And so it's the question. It's the big question of philosophy, of religion, of fundamental physics, like what happened before the Big Bang. These are all these deep questions. So first you start with any theory with a guess called an axiom, right? And an axiom is, for example, there's no mathematical proof in the world that exists without a guess in philosophy on the axiom that is presumed or guessed to be true. But you can't prove that the axiom is true. Same thing with physics theories. We say, well, we're going to presume that energy is fundamental, or we're going to presume that space and time are smooth and continuous versus pixelated. You guess. And then the interesting thing about these guesses is they really take you on a journey. Like you guess one way and it'll take you far left. I guess the other way it's the opposite. All right, so you start by saying, all right, is reality made of stuff or is it made of information? So if you go to Newton's physics or Einstein's physics, it's definitely made of stuff. Right? In Einstein's physics, we call this the fundamental stuff. So we have the fundamental particles. Examples are electrons, quarks, and photons, right? And then we say, well, what are those made of? And we say, well, those are made of nothing. Those are fundamental. And we say, well, so those are energy, right? So quarks and electrons are mass energy, and then photons are light energy. So we say those are the fundamental kind of irreducible pixels of energy. And then we say those are moving around and interacting in this other fundamental stuff called space-time. So that's it. You got the fundamental space-time, and then you got the fundamental units or particles of energy, and you pretend by guessing that those really are fundamental, and they are distinctly not made of information. Then you go to quantum mechanics, which most people nowadays agree should supersede or trump general relativity on a deep question like, is reality made of these fundamental physical things, materialist things, or is it made of something really abstract like information? All right, so I'm going to just do this, Tim, deductively, and so it's step logic. So now we
Okay.
say, all right, so what is that philosophy called when you think it's made of stuff? So that's an ancient Greek philosophy. It's a few thousand years old, and it was based in mystical concepts, and it's called materialism, right?
Okay.
Materialism, for some lay people, they presume that materialism is associated with science, but it's not. Materialism is a philosophy with mystical roots. Um, but in the modern world, where quantum mechanics dominates, quantum mechanics is unapologetic. It says reality is not materialist, it's made of information. Get
Hmm.
used to it, right? It doesn't apologize. The mathematics is hardcore. There are some naive things that we'll teach high school students called wave particle duality, where we kind of almost it's almost like we purposely oversimplify it for young students, and we say that sometimes it's a wave, which means a wave of probabilities. It's abstract, it's made only of information, not stuff. And then we say when you observe, it becomes stuff, it becomes particles, and those are little chunks of materialism, matter again. So
Oh,
that's wave
okay.
particle duality. But the problem with that is, unless one has technology to observe down to the pixelated scale of the Planck time and the Planck volume, which we don't have that technology, then every observation simply takes one abstract spread of probabilities made only of information, and it lenses it down to a smaller set temporarily of abstract probabilities. It can only go all the way down to one probability of where a particle will be in time or space if you were to be able to measure at that freakishly small scale of time and space, and we don't. So all we do is th move things from this probability distribution of pure information to that probability distribution of pure information. Materialism is dead relative to the 21st century's emphasis and full acceptance of quantum philosophy, because now we have quantum computers that are evidence that quantum mechanics is beyond true, and so on and so on. All right, so that's super cool, right? So then we can say it's a it's not a new age belief, it's not a fringe belief. We can say that the status quo belief, at least for quantum physicists or really educated people, is going to be that, of course, reality is not materialist. That's very old. It's made of information. I think John Wheeler said it best. He was the guy who coined the term black hole and one of the fathers of modern gravity theory. He said, we live in an information-based reality. He said an
Hmm.
information theoretic reality and an interactive one. Whereas we observe and interact with it, we change the information. All right, so let's then go through the step logic and say, what the heck is information, right? If we want to know what reality is, and we want to be able to get to a point where we have no further questions. But I have a question, which is great. I'll presume you're right. It's made of information. What is information? What does that word mean? Okay. So information, I think, is meaning conveyed by symbolism. That you need something general so that you're safe, so that everybody will agree. So I can say that that is a safe definition that most, like academic level people might agree to, unless they can find a counterexample of information that is not meaning conveyed by symbolism, right? Like if your symbols were 0 and 1, and you ask, well, what's the meaning? It's really primitive meaning, but it could be on, off, yes, no, up, spin down. but it's always meaning conveyed by symbolism. This podcast is meaning conveyed by symbolism in a particular natural language. And symbolism and meaning need to be broad. So what we have is we have meaning is very hierarchical, like metaphorically, letters have meaning, but you arrange them into clusters called words, which have meaning greater than the sum of the letters. Sentences have meaning greater than the sum of the words, and so on, without upper limit. It's hierarchical. That hierarchy is language theoretic. So information may be not just meaning conveyed by symbolism, it may be meaning conveyed by symbolic systems, i.e. languages. But then we're going to need a really generalized language. So let's say, all right, if it's meaning conveyed by symbolism and it can be any stratum in hierarchical emergent meaning, then what the heck is a symbol? And so we can go to mathematics to answer that question. And we can say a symbol is anything which can be thought of, right? So like in category theory, you can have an object, which is anything that can be thought of, mathematically definable. So what a symbol is it's an object, which is anything that can be thought of, that represents either itself or something else. It's usually representing something else, right? But it can also represent itself. Like a triangle, for physicists, usually represents change. It's the delta symbol. It's a triangle. It represents change. But we could also agree as to language users, we could say, well, hey, how about every time we write a triangle as a symbol, it represents a triangle. You see, there's no problem with that whatsoever. So that's called a self-referential symbol. So reality is these symbols, okay, meaning conveyed by these symbols, which are objects that represent themselves or something else. So let's go further and let's say, okay, well, it seems that we live in a geometric reality. And it seems that the geometric reality keeps changing, like a 35 millimeter film, but in 3D.
Yeah.
So then we could say, our first guess would be that the symbols of reality are geometric symbols. So geometric symbols are very mathematical. So we have these examples. So if you have a crystal or a lattice, like the checkerboard, and then you could say, well, there's this thing that's called the root system of the checkerboard, right? And you could say, well, that root system might look something like this, right? It's just you go to one of the edges and where it crosses another edge and you just kind of have this shape, okay? And then you can say, well, what are the shapes, of these higher dimensional lattices, like a cubic lattice, right? Or a 4-dimensional cubic lattice. And then you have a different shape called the root system for each one, okay? So I don't want to get too technical, but I'm trying to say that a shape is a symbol. And some of these shapes are very mathy and related to algebras, because those crystals that I mentioned are algebras. So if you ever see the hexagonal pattern of a beehive, that is associated with an algebra called the E8. We have many algebras. It's associated with the A2 Lie algebra, and it's also associated with something called the Eisenstein integers, which is a kind of pixelated or discrete subset of the numbers that we learn about in high school called the complex numbers. That it's a coordinate space on flat 2D, and so then that algebra that I'm speaking of, which is a ring or a sub-algebra of the complex numbers, that has a root system, which is basically a point with 6 lines coming out, and it's a pretty little shape. And so what we do at QGR is we build reality or physical realism out of these objects that are associated with these algebras, like the complex numbers are one of these 4 division algebras, but we use all four of them. So the division algebras include the counting numbers, 1, 2, 3, 4, and all the numbers in between, and that's on one-dimensional space. Then we have the next one up, which is the complex numbers, and then we have discrete versions of those, okay, made of integers, and then we have the next one up, it doubles. So 2 dimensions times 2 is 4 dimensions. So we have this 4-dimensional crystal, and that is the Hurwitz integers, and that's a subalgebra of the quaternions, which are the next one up of these division algebras. And then the party's over when you multiply by 2 one more time. Now 2 times 4 dimensions is 8D, and now you have these division algebra, which these are coordinate spaces, and it's an 8D, and it's called the octonions. And the octonions have a pixelated or discrete or integral subalgebra, and those are called the Klee integers. And that has a shape, which you can see as a point in 8 dimensions with 240 lines coming out of it, and it's a pretty shape. So what we do is we build a cycle clock by cycling mathematically one of the shapes of the 3 lower division algebras, those root systems, like the hexagon thing I said. We cycle those on these higher dimensional root systems. So it's all very abstract, but you can build these out in simulations, in computers mathematically. And what these things form is, we call them cycle clocks. So they are division algebraic and discrete cyclic group theoretic dynamic objects, and it starts in 8D, and then we project down to 3D. So in 3D, when you project a crystal, a periodic pattern in some dimensions such as 8D, and if you project it by an irrational angle, a slice of it to any dimension lower than 8D, you get something that mathematicians call a quasi-crystal. And an example of a quasi-crystal would be something you might see on a Muslim mosque.
Okay.
Or something like the Penrose tiling. So unlike crystals, these quasi-crystals are codes or languages because they have rules. And so the difference between a language and something that's not a language is a language is this set of symbols, could be geometric or any set of symbols, and then rules on how you can relate them. But within the rules, you have to have syntactical freedom. Okay, so you have things you can't do, but then you get these options on things you can't do. Like it's against the law in English to say the dog ran cat.
Yeah.
Can't do it. You have no freedom to do that. But you're not forced to say the dog ran fast. You can say the dog ran slow. And so that's syntactical freedom. So as long as you have strict rules of what you can and can't do, and you have a finite set of symbols, then that's a general language. You can build it up to express arbitrary, hierarchical emergent meaning with any language. So if you follow what I've said so far, I'm trying to suggest that perhaps reality is almost like running an algorithm, like a simple program on a mathematical game board, which are these algebras that live in spaces like the plane where the complex numbers live. So we have these algebras, and those are like game boards. And then think of running programs on them. Like you can have a section of what we call the Z2 lattice, and that's a checkerboard, just 8 by 8, 64 squares. But I could play various games on it, like chess or checkers. So then upon these algebras, we run these programs, like the cycle clocks that I was describing. And then we have these rules based on first principles axioms from computer theory, right, which is about saving bits at the end of the day. And then what happens is these things take on a life of their own in the computer. You create these 2 or more of these particles that we call quasi-particles, and they start evolving and forming complexity, right?
Okay.
And then one level of complexity will start forming complexity with other similar things at its level to form a third level of emergent complexity. And then after a lot of iterations, it can blow your mind on the sheer beauty and sophistication of the complexity. You know, like if you've watched a YouTube video on a 4K Mandelbrot set zoom, it's like a psychedelic thing to look at. It's mesmerizing and it's so rich and so complex. But if you look at the little simple program that is written to express that, and it never expresses that until you have millions of iterations, and then you see how complex a simple program can be. So we're saying reality is like that. So then you have to say, all right, Klee, I kind of get what you're saying. You're saying reality is made of information. It's like these particles playing out on this game board. I presume that you're getting probability distributions. And the answer would be yes, we get these vast probability distributions for how they can play out. It's all mathematical. And so you'd say, okay, but then what is reality? Where did that come from? Like, who's running the computer? All right.
Yeah.
So let me ask you to close your eyes and visualize a tic-tac-toe board. It's just 3x3 grid. If you can hold that in your mind's eye, right? Just close your eyes and tell me if you can hold that in your mind's eye. And if you can, then play tic-tac-toe against yourself in your own mind by laying down the circle on one of those 9 squares. Remember where it is. Then lay down the X as you play yourself, right?
Okay.
And then if you're focused, you can play it all the way out to the end and then open your eyes and say X1 or O1. And I didn't even know who was going to win until I played it to the end. So what you would have just done is you would have taken a mathematical game board, which is that little section of that's a section of the Z2 lattice, and then you played an algorithm that had a hinge variable because you were not allowed to lay down an X on top of an O. That's against the law in that rule-based program. But you weren't forced on where you have to put the next X or O. And so you, in a sense, you played out a game upon a piece of math. So if reality were like that, now imagine that a bigger mind, like a neural net mind from this new O3 model that OpenAI just came out with, that's probably early stage AGI. That could play it out on a bigger tic-tac-toe board. Maybe it could play it out on a 3D tic-tac-toe board. Maybe an 8-dimensional tic-tac-toe board like what we use at QGR. And it could play out a lot of these cycle clock quasi-particles. There's no upper limit in principle, right?
Yeah.
So imagine if you had a mind that is so great that it could compute or play out a program like this, like you did on the tic-tac-toe, but far more complex and far more iterations and far more like high resolution, like more data, more particles. And then that cooked along and played out, and emergent complexity occurred. Like, well, isn't that what happened in our reality? We supposedly had a big bang about 14 billion years ago, and early on there were no atoms. It was a quark gluon plasma. There were no electrons, and it was homogeneous. It was boring. Everywhere you looked in that small universe, it was pretty much the same thing, like a mist of this quark gluon plasma. And then it self-organized to a higher level, and we had hydrogen atoms, but there were no suns. And the hydrogen atoms were distributed as a homogeneous mist, very boring, but less boring than the quark gluon plasma. And then things continued, and those hydrogen atoms clumped up and self-organized into suns, stars. And then that eventually self-organized through gravity, and we had our first supernova in the universe. And after that, we had about 100 different atoms, not just hydrogen. And then they started self-organizing. And those atoms can self-organize into objects like DNA. And DNA can encode a protein folding algorithm and the instructions to make the highly conscious Tim Ventura, right? And so you see that this complexity arrow of time in this universe continues going. The universe is far, far more complex nowadays, with galaxy clusters and galaxies and solar systems and biospheres and economies, right? And societies and biology. It's just breathtaking what this complexity arrow of time can do from a ridiculously simple quark gluon plasma and a few really simple rules of quantum mechanics. So I'll end the story by closing the loop, right? So here I'll start with this idea of the simple program, kind of metaphorically like the quark gluon plasma right after the Big Bang, right? But in our picture, it's these cycle clocks and this mathematical game board. And then you play it, and in an unpredictable way, it becomes wildly complex. And life emerges, and life is able to compute, because to compute is to process two or more ideas and make a baby idea, which is an emergent thing from the first. That's the generalized idea of compute. So you can have a neural net like GPT-4 computes. You compute. You are capable of computing. And so a sufficiently large emergent mind-like thing that emerges in this universe that has this complexity arrow of time and mind-like neural nets, whether artificial or biological, doesn't matter. There's this black box of emergent behavior that nobody knows how biological consciousness does what it does, and nobody knows how in the world these new, large language neural nets are doing what they are doing either. But yet we know it exists, and we know it can compute. So if you get to this almost godlike, remember the Borg in Star Trek, right?
Yeah.
Like, imagine something that's even bigger than the Borg, a universal scale. Like, just take it to the logical upper limit. So now you've got a consciousness that is ridiculously vast, and it may not be a consciousness like ours, we just say mind-like, and we say that it can compute. It's finite because the universe may be finite, but its compute capacity could be exponentially larger than anything we could imagine, and it could be sufficient that it, which emerged from the code, okay, is capable of thinking of the code itself and running the whole program to become itself. Now that's a mind bender. So what if we were to just take that and say, well, if it starts simple and becomes complex and it's all made of information, then why can't we wrap that into a circle such that any place on the circle we can stop and say, where does that come from? So we stop at DNA. Where does that come from? So we understand quantum chemistry, and we know the answer. We can go to the simple program, the game board, and we can say, well, that was in the mind of the emergent pan-consciousness computational substrate. And then we can say, but how did the emergent pan-consciousness computational substrate emerge? And we can say, well, it emerged just like Tim Ventura's mind emerged. Somehow, from the vast combinatorics of trillions of atoms and particles in his body and the neural net of it all, this weird phenomenon called Tim Ventura-ness emerged. We don't really know exactly how, but we know Tim's real, right? And his consciousness is real. So that closed the loop, like in that symbol called the Ouroboros from ancient symbolism, which is a snake uh, connected to the head. But if you
Yeah,
stretch
eating
out
its
the
own
snake,
tail.
right, I'm sorry, the tail connected to the head, and you could say, well, what's the simplest and smallest part of the snake? Well, you could say, as the tail tapers off to one skin cell, it's pretty primitive in complexity and it's pretty small. And then the head is probably the most complicated part of the snake. It's got the brain and the eyes and it's bigger. So you could say, well, what if we wrap that snake into a circle and we say that the emergent head of the snake that self-actualized itself emerged ultimately from the code, the simple primitive little code of these geometric symbols. And we could say, well, where did the little symbols come from? Oh, they came from the emergent mind, the computational mind of the snake. And you really find that there's no logical flaw and that every question on the circle has an answer. So this is called a cosmology, and it's probably our most popular peer review paper, and that's called the self-simulation hypothesis
Yeah.
interpretation of quantum mechanics.
Well, and actually, that was something I was hoping to get into. So I should back up a moment. Several of the things, many of the things that you have talked about, I have been kind of struggling with myself, right? One of those is like the limits of language, the limits of linguistic symbolism. And so that's something that you are taking to an entire new level. So this is very, very heavy duty stuff. And I'm going to put links into the website as well as to some of your papers. I want people to take a look at that and read through it. But, when people start to go down the rabbit hole, right, and they start to get into this, I mean, many of the things that you've mentioned so far are starting to answer questions that I've been asking myself,
Oh,
right?
really?
So,
Oh, that's
oh yeah,
that
oh
that
yeah.
lights me up. Thank you.
Well, and so I'm going to go off on a tangent, but like, excuse me, like, so one of the challenges that I've encountered is, I do some consciousness interviews and things like that, and I'm not going to describe this well, but you have prophets of different, religions throughout history, right, who have these deep mystical experiences. And then you have these consciousness effects, right, where normal, everyday people, every now and then, they have something happen that they can't explain. And they can't put these things into words, right? And so one of the things that occurred to me was, okay, the limit is language, right? Our brain processes it, like it evolved to process in another way, beyond, in a more expansive way than the limits of what our language allows us to do. And so you're going exactly to that. You're
That's
saying that
right.
this is geometric in nature, ultimately.
Yes, it needs to be language theoretic in the end. And Tim, I didn't know that you had gotten this far in your thinking, so this is going to make a fun rest of this podcast. Can I share a screen to bring up a document?
Actually, in Riverside, I don't think it allows us to share screens. I mean, if you want, we could do another podcast in Zoom, another time.
Well,
But
I can read um, I actually can read these off myself, but I think you would love, and your audience might love, to hear what the seven axioms are of
yeah,
of
yeah, go for it.
cycle
Yeah,
clock theory. So the first axiom is uh, is all is thought. Okay, and I think you understand why, right? Because we reject the ancient mystical philosophy of materialism in favor of a more quantum philosophical and realistic idea that everything is information. And as you saw, how I created that cosmology for you called the self-simulation hypothesis, that we see that everything was thought. In other words,
yeah,
what were those little mathy geometric cycle clocks, made of? Well, they were just thought in the mind of this emergent pan consciousness computational substrate, right? Look, nobody nobody can reject on logical terms the possibility of a pan-consciousness. In other words, all we know is that somehow a bunch of energy and countless trillions of particles self-organized into Tim Ventura, and he's for sure conscious, right? We don't think he's an AI, and even if he is an AI, maybe he's a conscious AI, right? So
Yeah.
so the idea is everything is thought in this, right? And yes, it sounds crazy that you could have the Borg in Star Trek, but maybe you can, because Tim Ventura-ness also emerged from the collective behavior of a bunch of living little dudes. These living cells in your body, they will chase nutrients, they will run from toxins, they will multiply, they have their own way of eating and mitochondria. They make little decisions. And you can see a single-celled organism making a decision when you look at a YouTube video, or a documentary showing sperm cells moving. They're like little tadpoles, but they're single-celled organisms.
Actually, if I could jump in, this goes to, see, we must be on the same wavelength. This goes to another thing that has been just percolating in my brain for a while, which is that humans are part of a larger superorganism. And then the corollary to that, this is the part that intrigues me, is I have a feeling that we created a nervous system for it with the internet.
I think you're right, because as I plug my consciousness, my mind into the internet, I am adding information, I'm taking information. Now, in order for your theory to be possible, there would have to be part of the explanation in quantum entanglement. Quantum entanglement was at first an unapologetic implication of the mathematics. At first, it wasn't believed to be real because it's ridiculous sounding. But now it's well proven. It's also proven experimentally that particles can be entangled across time and not just distance and space. So now you can have a theory without anybody laughing at you that maybe Tim Ventura and his emergent structures can be entangled with Tim Ventura on Saturday, right? The 4th of January. And that would be an entanglement network across time because he's entangled with Tim Ventura here on the 3rd of January. Now that object, that system of the two Tim Venturas entangled to form a collective, an unimpressive small-time collective, because the Tim Ventura of tomorrow has barely evolved or learned more knowledge than today, but still it would be greater than the sum of the two individual Tim Venturas.
Yeah.
And so there are no deal killers in what you are saying. And in fact, in the self-simulation hypothesis interpretation of quantum mechanics that we developed, this across time entanglement is required in order for the whole system to work.
Well, and that seems like that might facilitate people who can see into the future, right?
Yeah.
If the future self is entangled with the present, maybe it's acting like an antenna of some kind.
Exactly. So now, so now I'm going to go to the next axiom, right? So the first one's all is thought, and with all that set up about explaining the self-simulation hypothesis. By the way, we call an entanglement loop across time in our paper, we call it a strange loop, which is a technical term from a famous book, the Gödel the Hofstadter's book. Now, so all of reality in this cosmology is made of these strange loops. Think of them like guitar strings or feedback loops, and you can mess with them, you can adjust them, and you can create a strange loop with something in the future or the past, and then you can upregulate the amplitude and the frequency. So they're very modulatable in our opinion. And so long story short, the next of the seven axioms, uh, after the axiom all is thought, is the axiom called the code theoretic axiom. And that is also one of our popular papers. The best way to see all 120 of our peer-reviewed papers is just to Google my name and then the name ResearchGate, right? And you'll get the first link will be
Well, and I'll drop links
and
into
you'll drop those
ResearchGate as
links.
well.
Okay.
Yeah.
Tim, maybe as a little gift to your podcast and its listeners, we can reveal in writing for the first time, because we have millions of followers and stuff, and so we've never released the seven axioms. And so I can give you those, and you can release that document to the viewers of
Oh,
this
absolutely.
podcast, and
Absolutely.
that'll be the first
Well, and
channel.
and it sounds like we may end up coming back in the future and doing a Zoom call so that you can do a massive screen share, But
Yeah, that'd be fun. Speaking of the future, right? Right. So the next axiom is the code theoretic axiom, and I won't spend too much time on it, but it really just says that reality is not just information theoretic, in the words of John Wheeler and how what quantum mechanics implies. It's information behaving in a rule system that includes
mm,
syntactical freedom, which makes it formally language theoretic. And the beauty of all languages, from bird languages to C++ to Morse code, is always hierarchy. Like the letter, word, sentence, paragraph, that is universal to all languages, emergent meaning. So the third axiom, so we got everything is thought. The information of thought is behaving in a language theoretic way. And then the third axiom is the axiom of finiteness. So a lot of spiritual, mystical people get pissed off when I say that reality is finite, especially if you want to include their notion of God in reality, to be included in reality, because nobody likes the idea, few people like the idea of a finite God. So first of all, let's just get clear on the word God. I'm not subscribing to any religion. I'm just saying that if you had something like the Borg in Star Trek that was trillions of times more smart and vast, or this thing called a universal Turing machine from computer science, which is a concept that says, well, what would it be like if all of the energy in the universe were dedicated to some vast neural net type of quantum computer or regular computer? What would that be like? Well, that's called a universal Turing machine. Okay, so that is where we can introduce the word godlike. Okay,
yeah.
like a
Well, and
godlike consciousness.
one of the things that I was thinking of earlier was if the entire universe participates in computation, right there, that is infinite in a sense, right? It
It
is
can be
finite. It would be unity, but then from our perspective, that would qualify
virtually
as infinite.
infinite, right?
Yeah.
Okay, so let's just beat up on this. Let's try to persuade your listeners to believe to those who believe in that there's a potential unification of consciousness and science, spirit and matter, whatever you want to say it. Like, let's face it, well over 50% of Americans have had an unexplainable supernatural type of experience.
Through time and through space and this is one of the things that really troubles me. And then with the UAP phenomena, I have been meeting more and more self-described experiencers who are saying there is knowledge and communication that's being shared, but again, it can't easily be put into words, and I think a lot of the time it can't be put into words at all, because you have people saying, I feel like I learned something, but I'm not sure exactly what I learned. And for me, it's kind of like, okay, that's the limits of language, right? It's
Yes.
our brain evolved to process in a larger, more expansive way, and we're trying to like put everything into these little boxes and say, okay, this is a word, this is a sentence, this is a concept, and if we're actually dealing with, like you talked about self-simulation, right? Creatures or us or AI from the future that are creating today's reality, or if we're talking about extraterrestrials that are millions of years more advanced than us, they're probably not going to use those same little labels and boxes. And if they try and communicate with us, they may be able to, but we're not going to be able to bring that home, right?
You got it. That's right, Tim. Well said. So on this third axiom, the axiom of finiteness, if you go to a person who, so many mathematicians, high-level academics who have had mystical, supernatural experiences, psychic experiences, and so on, and there's nothing in science that prohibits godlike consciousnesses that don't even require animal bodies, atomic physical bodies. Okay,
Yeah,
so
Penrose. I wasn't that what that.
the Emperor's New Mind, yeah, the
Yeah,
god that there could be a kind of almost like the Force in Star Wars, right? This kind of thing, and it does, and we don't have to anthropomorphize it. We don't have to know how it is. It's just plausible. That's all. And so we don't want to kill it because it sounds politically anathema to materialists. So let's go on and say that why do people get rubbed the wrong way when they think about a godlike thing that is finite? Well, they get rubbed the wrong way mostly because of stuff they learned from men. It's usually men who write these religious stories, right? And so the problem is, it wasn't until the 20th century that the mathematics of infinities were really developed to where we even can grapple with what that word means mathematically. And and so there wasn't a mathematically clear word of infinity in ancient languages. What they meant is more like Eric Zoolander in the Ben Stiller movie, where he was so good looking as a model that he would say, really, really, really good looking. In other words, they would use metaphors in the ancient texts like God is like all the sands in all the beaches of the entire world. Well, that's a lot of grains of sand. That's
yeah,
virtually infinite. In other words, if you have a God that is exponentially trillions of times more conscious and aware and big than you, what's the difference between virtually infinite and some abstraction of mathematics that you don't even know what the word really means called infinite? So, what we're working with is the axiom of finiteness, which is beautiful because you know that adage, there is nothing new under the sun. That is an adage that comes from this idea of infinity. Imagine a God that is already thought everything. It's already heard every joke, every beautiful piece of art, every thought. It's just burnt out. There's nothing, no more fun, no more childlike joy of epiphany. So that's kind of a bummer. But what about a God infinitely reaching toward the infinite? That is a universe where there is always something new under the sun possible, where growth and expansion, even of this idea of God or the Force in Star Wars, and that makes, and if it's an emergent God versus a God that was in a good mood one day and blessed reality with the gift of creation, but in no manner needed reality for its own existence. Now we're talking in the self-simulation hypothesis, a spiritual God-like concept that is fully integrated with
so
us.
yeah, so is this in this model, God is participatory. And then one of the other things, and I know this is very heretical, I'll probably piss people off, but one of the things that I felt for a very long time is that people have had these deeper glimpses into reality, right? Again, many
Yep.
famous prophets, they bring that back, they try and communicate it to people. People don't understand it, so they write it down as a bunch of rules. They mix it with social customs, and it becomes a religion, right? But that is very different than the insight that led to it. So I think that goes exactly to what you're saying. It's participatory.
Yes, and it's emergent, even more than participatory. It's a God that needed us and needed all of reality for itself to exist, just as we need that emergent pan-consciousness computational substrate in order to have the mathy game board and the simple algorithm that would eventually lead to life, biology, consciousness, and then beyond. And so the fourth axiom follows from the third axiom. In other words, if this God-like, finite but God-like pan-consciousness computational substrate of this bootstrapped, self-actualized, self-simulation universe had infinite mind, it has infinite computation, which means it should have no logical reason to be concerned with efficiency of computation. In our case, it's the opposite. It can become more of itself with less of itself if it becomes itself efficiently. So this leads us to select efficient mathematics. Let me give you an example. Heisenberg developed modern quantum mechanics. 1 year later, Schrödinger came up with a competing formalism called the wave function formalism. So it was made with a mathematical function called a wave function, and Heisenberg's competing approach was using matrix mathematics. These two mathematical formalisms or algebraic approaches are so different looking that everybody knew that these theories were competing. They weren't equal, they weren't isomorphic, as we say. But one of the smartest mathematicians, Dirac, came along after about a year and he said, hey guys, I know we're all debating about which one is the truer formalism, but I've proven their equality. They are isomorphic. Now, okay, so they both generate the same probability distributions, right? The same physical realism. But which one, in its most reduced form of symbolism, would require the fewest bits in a binary irreducible language? Let's say, for sake of discussion, that Heisenberg's matrix math approach required less bits to do the same thing. So then if the universe could only choose between those two formalisms, the principle of efficient language says that the universe is greedy for efficiency. And so it will choose the matrix math approach between those two. So we use extremely powerful economic mathematical formalisms such as Clifford algebras and division algebras, the four division algebras.
That almost seems like a minimum energy state, or what would they call it, an energy well, except in terms of information, right?
You got it. So Shannon entropy, and so when you look at the idea of Boltzmann's entropy, thermodynamics, as we call it, it's all about what we call the least action principle, which is an energy conservation efficiency principle. And then you find that this physical entropy called Boltzmann's entropy is actually Shannon entropy in disguise. I'm not rattling off my own hypothesis there. That is kind of an established thing for people that are expert in this. Shannon entropy is physical entropy, and we see this most explicitly in quantum black hole physics equations, where we'll use information entropy, aka Shannon entropy. So good point, Tim. Now, so this is why we're using these discrete subalgebras of these division algebras, right? Because for efficient computation, you'd want to use integers, not the infinity of numbers in between. So I'll move on to the fifth axiom, but you'll see how they're building on one, or they're interrelating. Because if we didn't have the axiom of finiteness, there would be no motivation to have the axiom of efficiency, right? The principle of efficient language. And and then again, we say language because of the code. Language and code are interchangeable words. And so we say efficient code, efficient use of, you want to use the code efficiently and you want to pick the most economical code, right? So you want to pick, so codes, math, an algebra is a language or a code, okay? So what we do at quantum gravity research is you can say that we're doing a mashup of somewhat sophisticated mathematics, pure math, and computer science.
Yeah, and I love that. That is a new school approach. And I think that, I mean, this is just my thought. This emerges from 20th century physics, but in a way, it feels like it has left 20th century physics behind. And one of the things that I see is, I got into computing during the dot-com era. And so I fell in love with Ray Kurzweil and a lot of these information theory ideas. And it was a challenge to bring this back to people who came up in the older establishment because they didn't think in terms of information theory. They were thinking in terms of physics, right? It was particles and energy and wave functions. And it was like, okay, yes, that makes sense. But if you take some of these concepts and you put them into this metaphor of information, it makes it a lot easier to use. And I think that we've seen some things like Wolfram's A New Kind of Science emerged from that, right? Where he was starting to talk about fractals and self-emergence and things like that. So these ideas are out there, but it feels like they haven't reverse propagated back to the older physics establishment yet.
I'd love to comment on that. Do we have the ability to go long?
Yeah, yeah.
Okay, cool. Because I got time. So yeah, first of all, Stephen Wolfram, you mentioned Stephen Wolfram, you mentioned Ray Kurzweil. So they were very influential in my 16-year journey. So for 16 years, I've been like a full-time scientist, director of QGR, where we mostly employ PhD level mathematicians, computer scientists, and physicists. But in the very beginning, it was Ray's book, The Singularity is Near,
Okay.
that got my attention. And and then and then I got together with Ray and a guy named Peter Diamandis at NASA's Ames Center one day, and Larry Page from Google was there, and the director of the NASA Ames Research Center, which is like the brain of NASA, was there. It was only 30 of us, and we were meeting to discuss forming Singularity University, which was
Okay.
to be an institute that would synthesize and cross-pollinate the siloed things in universities that are usually siloed between, computer science where we're studying, artificial neural net and strong AI and genetics and whatnot. So we would synthesize these things and then fixate on what we called grand challenge problems. That we defined a grand challenge problem as any problem that if you solve it, it will impact at least 1 billion people. If it
Okay.
impacts only half a billion, it's not a grand challenge, right? It's just a made up number. But so and it was about synthesizing. So I was probably the first person at that meeting to raise my hand and donate money because I was hooked and sold right off the bat. And then I went back to Los Angeles, where I live, and this was before QGR was founded. And I thought, oh my God, business and making money is so boring compared to discovering the keys to the kingdom, the fabric of reality. I want to know what is reality, and that is where, even though that wasn't the topic of that meeting in Palo Alto, it was kind of what I came back with because I was in the presence of a bunch of geeky, smart people who wanted to do good for humanity. And I thought, well, if we could just find out the nature of reality, then it could be good for humanity. And then I started learning that there exists no first principles theory of anything. So a first principles theory would be something based on mathematical first principles. So if you look at, for example, say string theory, which attempts to unify the two most powerful theories we have, which is the theory of time and space, that's general relativity, and then to wire that up to make sense with the theory of everything else, which is energy or particles, um, which is represented by quantum mechanics as the best theory there. So what happens is we take these fundamental constants, which is c, the speed of light. Nobody knows why it's that speed or why there's even a speed limit. And then Planck's constant, which relates to like this minimal unit of action that can happen. It's really small. And then that relates to a pixel of space and time called the Planck volume and the Planck time. It's just ridiculously small. And then the gravitational constant, which tells you something about the curvature nature of reality with respect to gravitational theory. So those three numbers, just think of them as three numbers. What we do in modern physics theories is we say, we wish we knew where they come from, and we wish we knew what the numbers even are, but we do not know what the numbers are past about 5 places after the decimal. We just don't know what they are. And because we don't know what they are more than a few places after the decimal, it also means that we can't have an algebraic expression. Like if you want to express the golden ratio, you can write it out and you can know as many trillions of places after the decimal as you can compute. So we don't have the numbers, just approximations, and then we don't know where the hell they come from. But we are clever, and we found that if we mess around with equations, we say, oh my God, the three numbers, c for speed of light, h for Planck's constant, and g for the gravitational constant, we know that they relate to each other because we're finding that we can mix and match them. And like if you have quarters, dimes, nickels, and pennies and dollar bills, you can kind of start figuring out, oh my God, I got all these combinations where they can all become a dollar bill in these different ways, right? So they all relate. And so that we know, but until we know why they are and know the real numbers, we would not have a first principles theory.
Okay.
Right? Okay, so what I endeavored to do 16 years ago, arrogantly and audaciously, like I had lost my mind, is, well, maybe I can come up with the first ever first principles theory of everything. Why? Well, maybe because I'm a weirdo and I think in non-local weird ways, and sometimes I can see things that maybe 1 out of 100 times turn out to be brilliant, even if 99% of the time they're stupid. And I also realized that really smart people had been trying to crack the code on even a non-first principles theory of everything for over 100 years. Einstein died in the 50s trying to get something that worked. String theory is now about 60 years old, and it's made some predictions. None have ever come true.
But one thing that you have as a tremendous advantage, and I have seen this with your work, and I've seen this with this new school information theory approach, is the idea of meta-analysis. And like when you go to Einstein, I know so many physicists, and all of them tend to have that one pet model, right? Where they're like, I love this shiny object. I'm going to polish it, and if I polish it enough, it'll be perfect, right? And one of the things that I'm seeing come out of this new school information theory approach is being able to say, okay, here's one model, here's another. How do these relate to each other? And not just these two, but here are 1,000 different theoretical models. And what can we understand and infer by comparing them? And that's one of the big things that you have.
Thanks, Tim. It's because I'm an outsider, so I'm not religiously or emotionally attached to any pet model. And so what I can do is take some good models that others have done. And when I say models, let's include some algebras, pure mathematics, some concepts from computer theory, some physics models. And I'm free with no emotional politics to mix and match. And the thing about combining things is, oh my God, sometimes I I impress my layperson friends by telling them, hey, if you had, 20 people at a tiny wedding and you tried to look at all the ways you could line them up in a row to create a wedding photo, how many ways do you think you could line them up? And when I tell them, well, it's actually like these giant numbers, like all the particles in the entire galaxy type numbers, they don't understand. And that's the thing about combinatorics. So yeah, so so going back to the axioms, right? So we built up to this last axiom called the principle of efficient language, and for us, that is our one of our north stars. It explains why everything in physics has a what we call an energy conservation type of path of least action, if you will. Everything. I'm talking about that's in gravity theory with general relativity. It's in quantum mechanics. It's in thermodynamics for sure. It's everywhere. It's in all physics. For some reason, the universe is trying to behave economically in terms of how it uses energy and action, right? Everybody agrees on that. And so here's the philosophical or axiomatic underpinning in a computational concept of why. And so because we can reduce all of our math to a binary bit representation, we can count. Like we literally can count the bits and say, well, that algebraic formalism to get the same solution is just more economical. It'll save us electricity on our computers, literally less
Yeah.
logic operations. All right, so let's go to the fifth, sixth, and seventh axioms and we'll be faster. The next axiom is the closest axiom to sacredness, and it's called the axiom of unknowability. So we're going to rely on computer theory. In computer theory, I told you that there are these abstractions called universal Turing machines, right? A computer made of all the energy in a finite universe. And so then we have a category of problems that the universal Turing machine cannot solve in finite time. And we call them non-computable problems. So you might wonder how serious this problem is of non-computable problems uh, in a finite universe like this with a universal scale computer. Turns out that the consciousness, right, of Tim Ventura is included as a member of the large set of fundamentally provable non-computable problems in a universe where everything is dedicated to a powerful computer. And you could say, well, Klee, what if it were a universal scale quantum computer? I would say, well, then you could maybe resolve Tim's consciousness, but not me and Tim's consciousness both. That would outpace it. So this is really interesting, right? Because and the truth is, a universal scale quantum computer could not resolve Tim, your consciousness, Tim. It is. I told you, 20 people. The interactions, combinations of just 20 objects would get to numbers that are ridiculously large. You get to the countless trillions of interactions and entanglement events and dipole shifts and in your mind, in your brain body system, it is so deeply and thoroughly into the set of non-computable problems by a universal scale quantum computer. So what then do we say about this Tim Ventura's consciousness where it's in a reality of an ontology of that's based on the axiom of finiteness, right? The universe eternally reaching toward the infinite. Well, we can apply a word to Tim's consciousness called ineffable. Ineffable. Okay. In other words, hell yeah, you can know all kinds of things about the behavior of his consciousness. You can discover all kinds of primitive things at the local neuronal interface level. You can discover drugs that will alter his consciousness. You can model small clusters of atoms and all their combinatorics. So you can study, psychiatry and psychology can go way beyond. We can know way more than Tim Ventura than we know now. But we will still never be able to get to the deep meat of the good stuff in the black box of his consciousness ever. It's flat out. You'd have to have a near
So
infinite universe.
you're really talking about the hard problem then, in a sense, and saying
I'm
it's
talking,
unsolvable.
yes,
Okay.
but I'm extending this to the black box of modern large language models. So the first paper came out over a year ago from Microsoft Research. It took 100 pages to discuss in this peer review paper or in this paper the the unexpected, inexplicable behaviors of GPT freaking 3.5, which is
Hmm.
ancient technology at this point. Then, many months later, another paper came out by Microsoft Research on GPT-4. Now, GPT-4 was a pretty good leap above 3.5. And the quantity and quality of the shocking black box behaviors that computer scientists believed couldn't even happen, and they don't know how it happened, was more. So as we get into what's O1 preview, like I have the $200 a month subscription to O1 Pro, and it's really smart. And now I've seen that OpenAI is accepting invitations for early testing access to a model that eclipses that one, right? The O4, the O3 model. So the point
Yeah.
is
Well,
as these neural nets get more intelligent, the black box behaviors that we will never understand grow further and further out of reach. And this has been a long-standing problem for neuroscientists. It's hopeless to fully understand what the hell how this happens, consciousness.
what now? Do you think? And I know we're going way off on a tangent. Do you think that this is the emergence of the singularity? Some have said that the singularity is a process, and we're at the beginning of it, or maybe we're past the beginning of it. But
Yeah,
ChatGPT caused me pause.
yes. So again, I started quantum gravity research by first geeking out on the deduction from Ray's book. I told you Ray he was part of us. He was with us when we funded Singularity University, but that so blew my mind because I owned the deduction. Like I'm like, how can he be wrong? I followed the logic and I thought, wow, this is going to happen, just like in the movie The Matrix, right? And so obviously that's what's happening now. Nobody thought it would be this soon, but in 2025, this year, by the end of this year, we will be smack dab in AGI, not nascent AGI, but legit AGI.
Yeah, now going back to Kurzweil, I had for me it was the Age of Spiritual Machines, right? And I was working in Redmond in tech when I read that, and it was just like,
Yeah,
religious
yeah,
experience there.
yeah, yeah.
But um over time, I mean, there's so much to unpack from that, and I've had so many little minor epiphanies along the way. One of those that got me though was when Ray showed the exponential increase in computing, and he showed it from biological systems into machine systems. For me, over time, I came to the feel like machine intelligence is part of nature, and it's part of a natural evolutionary process. And I would tend to distinguish that. I know this makes me an outlier in terms of thought, but we tend to think of ourselves and nature as natural, right? This is what we have, and then we create the artificial. And the interesting thing that I kind of took away from that is this blurring where at some point in time it doesn't matter, right? Maybe the only difference is, like you said, it's information or intentionality behind design rather than evolution. But
Yeah. I think, Tim, it's helpful if you're open to bifurcate into two words what a neural network is and what its emergent mind-like behavior is versus what a computer is and its behavior.
yeah,
So yeah, so this I'm sure I'll be speaking shorthand to you. So you are not a computer, but you can compute. Okay,
yeah,
so as a neural net, you're not fundamentally a computer. And that's why these emergent behaviors of these neural nets were not really good at computing back at the 3.5 level. And you're not even very good at computing. A 1975 calculator is better than me and you at computing. But nonetheless, we can compute. And we can also imagine that if we had minds that were 100 times more powerful, that we can compute even better. So neural nets have this ineffable quality that we call in computer science, in neuroscience, we call it the black box. The black box is growing as though it's getting further out of reach, not closer. Whatever the hell this ineffable substance is, called consciousness or mind-like behavior, I don't care what word you put on it, it's fuzzy. I've been going to with Roger, Stephen, you mentioned Stephen Wolfram, Roger Penrose, Ray Kurzweil, right? I've been lucky enough to connect, with all of those. Stephen Wolfram's the closest friend of those, and he's been, here in this room actually, where I'm sitting with me. And he's pioneering boldly, with lots of criticism from the physics community, this idea that maybe reality is based on simple program philosophy, right? Ray Kurzweil's more old school. He is still, at least last time I checked, still fixated on the compute approach. What I'm suggesting is the neural network approach, where something weird emerges, the black box. And yes, it can compute, but it's not a deterministic algorithm playing itself out. I think your listeners would appreciate this easy to understand fact. Generally, a computation is what we call a deterministic algorithm playing itself out. Okay. So if you run it twice, you'll get the same thing both times. But that is not what happens when you ask Midjourney or GPT-4, to write a poem, or Midjourney to create a pretty image. What they're doing is they are jacking in to nature the way that Morpheus would jack into the Matrix, right? With the thing grotesquely in the back of the skull. So when you jack into nature and suck out this substance called randomness, so we don't know where the randomness comes from in quantum mechanics, it just is. Humans cannot write an algorithm to make randomness. We write algorithms to create things called pseudo random number generators. In other words, we could go back to that word approximate or virtual. It's kind of random, but if you want to get down to the bottom, it's totally deterministic at the end. Not so with these large language models. So what happens is you can think of them as code theoretic, language theoretic. I said languages cannot be deterministic algorithms. They have to have this hinge variable called the syntactical degree of freedom, which within the rules gives you two or more options. So that's what happens in these generations. You say, write a poem about my podcast and the Penrose tiling. And oh my God, it will write a high-end, artful, beautiful poem, but two completely different ones with the exact same prompt. And if you go to 1,000,000 times, it'll be 1,000,000 novel and beautiful ones, 1,000,000,000. You could keep going. It will be different every time because it's jacking in to the weird randomness of nature itself. That is what your mind does in quantum biology.
And going back to the AGI aspect of this also, critics of LLMs have said, well, it's just picking the next best word. But the part that gets me, having used ChatGPT, and I haven't used the versions you have, I'm just talking about the older versions, 3.5 and 4.0, every now and then it has that spark, right? Where it'll do something or say something and you're just like, oh my God, that's AGI right there.
That's right.
It's greater than the sum of its parts.
Yeah, you're not, thank God you're not hearing people in the last half of 2024 trivializing these neural nets with
Yeah,
the same language like that, because now everybody knows, look, human consciousnesses are constantly predicting the next word. Like, watch, Tim, the dog ran statistically, right? You're going to say fast because that's what your
fast.
training data tells you.
Yeah,
But you're unpredictable, so you could mess around and say slow, right? But the higher probability is that if I jumped on you with the surprise, you would have said fast, okay? But not guaranteed. You are also looping back and looking forward and iterating, not just predicting. So it's like this it's like this idea of biased arguments where you pick out only the facts that support your argument and you leave out super important details. Those people saying that, they knew even 6 months ago, they knew, if they're a computer scientist, no. First of all, the machine is jacked into quantum randomness. Second of all, it's looping back and looping forward, and it's trying to make sense of it, and it's not just a statistical prediction engine.
yeah. It's not just next best
And
word.
now with the reasoning models, like that's out the door. Nobody's going to be trivializing, as much that way. So let me blow through the next couple axioms. So the last one
Okay.
is this axiom of unknowability. I promised you that that would be the most spiritually inspiring one, because for something to be unknowable is kind of like pretty. Like you can see that I am a hyper reductionist. Like I'm reducing all the way down to the bit, right? And mathematical objects. But I'm also a hyper complex systems theorist. And I'm saying that it just keeps on going in complexity. So I'm trying to go to both extremes of that bookend. How can I get to a reductionism where it's literally satisfying and impossible to reduce any further? Like I'm done, right? No more. That's the simplest thing. And we do that. And then we go all the way to this abstract thing. Now it's ineffable, that pan consciousness emergent substrate that can compute it all, but so is your consciousness. And so then we can connect them together. So that's the axiom of unknowability. You can use a fancy word from spiritual literature called ineffable. It's so mysterious, so beautiful, so big that there's no good words to put on it, right? You can't precisely know it. Now, if that consciousness is the only thing that I will never get my arms around and fully know, but I can know everything else. I can have the keys to the kingdom down to the irreducible pixel of information and all the way through, then that's good enough for me. And that's better than just plugging constants like C, H, and G. And it allows me to say, you know what, if anything is unknowable or sacred or ineffable to that level, based on this computer theory fact of the unknowable problems, non-computable problems, well, that's a pretty beautiful thing to be
Yeah.
so sacred as and ineffable. So the next axiom we touched on in other words, and it's the fifth axiom, and it's called the axiom of transtemporal causality, right?
Mm,
So we
okay.
all know from our training as animals that when we do this, it does that. So that's forward in time causality. Turns out that the way the math works in quantum mechanics is the math if the math doesn't care about politics and somebody interpreting the math is honest, the math of quantum mechanics goes both ways.
Yeah, the Feynman diagrams
The
are not.
Feynman diagram, right?
Yeah.
So one day Wheeler, we mentioned Wheeler being the guy who said we live in a information theoretic universe that's interactive with us. Those two guys got together and started thinking, well, they artificially stripped out the retro causality, the causality from the future to the past. They didn't have a good excuse mathematically to do it, but politically or culturally, people didn't like the idea of the future influencing the past.
So
They only liked the idea of the past influencing the future. They stripped it out.
that would be
They
like Bohm's pilot wave, right?
Yeah.
Or
So
okay.
yeah. So then these two guys, Wheeler and Feynman, I mean, these guys are freaking rock stars in terms of their creativity and their mathematical prowess. They wrote it the way the math kind of wants to be written without artificial stripping something out. And it's called the Wheeler-Feynman handshake. And
Mm.
that's a mathematical operation that integrates the influence from the future and the influence from the past into the now, right? Into the system you're trying to predict and model the probability distribution. So we just take the math seriously enough that we state right in one of our 7 axioms, we just say, look, man, the math is the math. This is also experimentally demonstrated, by the way. Causality works in both directions. It's almost like a guitar string. It's a feedback loop. And we call those, again, strange loops in the self-simulation hypothesis paper. So anyway, so that's an important thing because otherwise we would not have been able to close the loop on that kind of Ouroboros symbol of the snake's tail and the head and connected. And then the last axiom we also touched on early on, and the last axiom is called the axiom of self-referential symbols. And it's on the surface, it's the most boring of the 7 axioms, but it's also important because it's the thought that is the most novel. I'm not saying I'm the first person to think of it. It's just that I haven't come across anybody in the literature who has thought of it, but I don't spend my time reading all of the literature. But the point is that if you want to build a mathematical reality the way that, say, Stephen Wolfram does, right, out of simple programs, you're going to want to operate your simple program, in my opinion, on an algebra. He doesn't like to do that because he told me, like at one point, Stephen Wolfram told me, Klee, if we were in a race to see whose simple program approach is going to achieve physical realism first, the money would be on you because you're using algebras that are already used in the standard model of particle physics, like these Lie algebras that I told you about. But nowadays, I think he would say that he would win the race because he's had some breakthroughs. But he uses what we call graph theory, which is not an algebra per se. We we also use graph theory, which is where you're connecting things in these.
Now, isn't his more like the tiles in the old computer game of life? If I remember correctly from his book, there was kind of a tile based one of the,
No, he's on to some new
okay.
stuff nowadays. So that was his book called A New Kind of Science,
Yes.
where
Yeah.
these programs called cellular automata make shockingly complex things. He's advanced to a different abstraction with his
Okay.
program called Wolfram Physics, and that's based on this abstraction of graph theory, which can be in a higher dimensional space, and then you update the graphs and you have little rules in the graph updates, and then with sufficient iterations, you get these emergent shapes and emergent behaviors that are reminiscent of fundamental physical systems. So he's making some neat progress in the last like 3 years, and I'm really rooting for him because he and I have a friendship that's based on, okay, we both have multi-million-dollar companies. We're both distracted by those companies, but our real passion is discovering the keys to the kingdom, the first fundamental, theory of everything. And our approaches are very similar. Like his approach is the closest on the planet to ours in some ways. It's just that we're more hardcore with the math, the algebras. We're using algebras. He's not. He's using graph theory. But the point is with this, last axiom, the axiom of self-referential symbols, we're using these things I defined earlier as root systems, and it's in this network of these 4 division algebras, an 8-dimensional one, which is constructed, okay, of 10 copies of the 4-dimensional one. 10 orientation classes. Like, for example, let's take a cube, a cubic. How about an infinite cubic lattice, right? Like a 3D checkerboard. Well, obviously, you could make a 3D checkerboard with a stack of one of the 2D checkerboards. Okay. Similarly, you can make this 8-dimensional division algebra, the octonions, out of 10 orientation classes of 4D crystals in 8D space. And then you can make either one of them from these 2-dimensional algebras on the complex plane that I talked about, and you could make any of those three with the 1-dimensional algebra, which is the integers, 1, 2, 3, 4, 5, which is a ring on the division algebra called the real numbers. So these 4 algebras are what we call geometric spatial algebras. They form coordinate spaces in flat Euclidean spaces in 1D, 2D, 4D, and 8D, but they all kind of internest and build up to one another. And so a cycle clock is basically you're taking these shapes, these root systems of the lower dimensional ones, and you're messing around with these cyclic groups and how you can like cycle them. Like a simple example would be, take a triangle. It's got 3 sides. It's a regular triangle, same length. And you just kind of turn one of them on and then turn that one off and turn the other one on and then turn that one off and turn the last one on and just keep cycling like that, right? That would be a super simple example of taking these lower dimensional 1D parts of the triangle and cycling them to make a pattern, a mathematical pattern that relates to something called group theory, and these are cyclic groups. So anyway, so that's what we do, Tim, and soon this year we'll be, publishing to our followers and in published things these early stage probability distributions. So we are trying to get probability distributions for how 2 or more of these particles called cycle clocks evolve and
Okay.
complexify, over simulation time. And we're trying to get all of the behaviors and the probabilities to match up with quantum mechanics, right? And general relativity, and to get the physical realism and the constants, C, H, and G, from the first principles of just running the simulation based on these really simple programs and first principles of savings, right? So we have the savings principle where the probabilities are based on the savings of bits. So there's always, like if I took a random number generator and I used it to pick between 2 things, A or B, but I put a weight on A of 2/3 and I put a weight on B of 1/3, then the random number generator still makes a random choice, but statistically, if you do it a billion times, it would have about 2/3 of A, right, randomly picked. And so when we save these compute units with different ways that these cycle clocks can evolve in the simulations, and the ones that save the most bits have the highest weight, right, for what, for in the probability distributions.
Hmm. Yeah, so there's so much. You have covered so much today. Okay, so you were going to talk about where you and Jack overlap. You and Jack Sarfati, your
Jack
model.
Sarfati, yeah. So Jack Sarfati is, he's a great fundamental physicist, PhD, brilliant guy. But like me, he really doesn't care what people think, and he's not in a political system like a university where he'll lose his tenureship if he talks what he wants. And one of the most radical things that he says is that aliens, ETs, UFOs, these things are us from the future. In
Yeah.
fact, he even believes that early in his life he was contacted by one of these people from the future. That sounds like it could put you into a mental hospital if somebody didn't like that thought, right? Sounds crazy. I also think that I was contacted by our descendants from the future. In fact, I have all kinds of plausible reasons why the exchange of meaning in the form of consciousness can occur across time. That does not mean that an electron or a photon is moving across time, because for that to happen, you'd have to go faster than the speed of light. But we don't know what consciousness is, which means scientifically we don't know what thought is. For many years, I've attended and spoken at the conference, with the big conference, over 1,000 scientists at the University of Arizona, that Roger Penrose and Stuart Hameroff put on, and David Chalmers, and they organize this, and we bring together quantum theorists, philosophers, psychologists, neuroscientists, and we argue about what consciousness is and how it emerges, and we all agree that there's no consensus definition of that English word consciousness. You
Yeah.
you you talk about the hard problem, which is like, well, how does consciousness emerge from stuff that's not conscious? That's the hard problem. But the even harder problem is just defining the word consciousness in a way that you can get a majority agreement from your scientific peers. Then you can't. And there is no, then that's because it's ineffable. It's a black box. It can't be
Well,
defined.
and I don't mean to interrupt, but this goes back to one of the things that I've been wrestling with lately. And I think that ChatGPT factors into this. One of the things that people tend to confuse consciousness with is language manipulation, right? And again, when I see that spark every now and then when I'm using these AI tools, for me, that's what says there's something more here than simple language manipulation, right? It's able to make that leap. And what you're talking about is even greater, because you're talking about, like, I think most of us have had a dream that comes true, right? Or
Yeah,
maybe deja vu experiences where it's like,
right.
okay, I know concrete bits of information that I could not possibly have known otherwise. But
Thank you.
again, most of the time we can't put that into words. So,
Exactly. So here, I'm going to rattle off, I'm going to state a thesis, and then I'm going to rattle off a bunch of evidence in support of the thesis. The thesis is this: aliens, ETs, all of this that we see are our descendants, aka us from the future. So
okay.
now I'll rattle off evidence. Number one, we've spent billions of dollars and the last 65 or so years under the SETI program of NASA, pointing radio telescopes at countless billions of locations in time and space.
Yeah.
We've looked everywhere. And after more than half a century, the original scientists from that program are known to comment, we're absolutely dumbfounded that there's no evidence of life when we look into the past. It is at, or what amount of the present we can see. They say, it is so quiet out there, it is as though we are the first. So let's talk about first. And so that's the first evidence. You do an experiment at the cost of billions of dollars of taxpayer money. The scientists are assuring Congress that we'll hear something because of a model that says, well, think about how many stars there are, and think about how many stars have a Goldilocks distant planet with water, and then think about how easy it is for life to form, and then do the math. How could you be so arrogant as to think that humans are the first? It doesn't match up statistically. Turns out that their assumptions have a glaring flaw, and I'll get into that. Evolutionary biology abhors a vacuum. What that means is biology abhors anything other than balance. So, give you an example. If any predator-prey system anywhere, from plants to bacteria to animals, gets to a place where a mutation occurs in the DNA that causes one animal in a predator-prey ecosystem to be significantly smarter, faster, stronger, it will kill itself within a few seasons. Example, you have a pride of lions on the African savanna. These cubs are mutated to be a full 20% more intelligent than the normal lions. They grow up and use that out of balance advantage to outsmart the gazelle population that season so severely that within about 2 seasons, the gazelle population drops below the critical threshold, and therefore the lion species itself is snuffed out, almost as though the mechanism of natural selection kills off the mutation that gets too out of balance. So what the hell happened with Homo sapien, where the brain to body mass ratio is grotesquely out of balance with virtually all other animals? I mean, our brain to body mass ratio is nutsoid. Plus, you
Yeah.
have this one of a kind prefrontal cortex built for storytelling. We are the only animal, I, as a Homo sapien, am the only animal like the other humans who can worry about how I didn't pay enough taxes in 2020. Therefore, the IRS has a 60% probability of auditing me this year. I'm going to lose everything. I won't be able to pay for my daughter's college tuition next year, and she is going to become a pole dancer. So other animals don't have the ability to create story arcs across time,
Yeah.
right? And much less the ability to discover advanced algebras upon which nature works, like the complex numbers that are part of quantum mechanics, and so on and so on. There isn't, if you take the second most abstract thinking intelligent animal on Earth, it doesn't come remotely close to humans. Not dolphins, not jellyfish, not chimpanzees. We are freaks. We should have been snuffed out long ago. And we could have gotten snuffed out. We are killing our food supply. We could have had the Bay of Pigs Cuban Missile Crisis caused the release of over 40,000 nuclear warheads across the planet, which would have snuffed us out. It wouldn't have snuffed out cockroaches and bacteria, right? But that didn't happen yet, and we're about to get off planet. As long as we get off planet, the rest of us can blow each other up, and the genie will have been let out of the bottle. So how many rearrangements of DNA have we had? And has there been anything other than DNA-based life? So there have been 100 million different rearrangements of these 4 letters. Some make dinosaurs, some butterflies, bacteria, and one of them makes humans. 100 million. 90 million have been eliminated. They are gone. And we have about 10 million today. So that's 100 million. Now, if you go to a statistician at the local university and you say, hey, I'm working up this argument that there's life, intelligent life all over the place, I'd like you to bless the fact that the statistic I should use should be 1 out of every 100 million. He would say, give me your data. How many times did the event happen? You say 1. What's your total universe? 100 million. He said, get the hell out of my office. You can't take a sample size of 1 and just try to plug. If you only had 3, if there were only 3 out of 100 million, I'll build you a model and tell you within a range of probability. But when you have a sample size as small as 1 out of a number as big as 100 million, sorry, a statistician will laugh you out of their office. So we don't know if it was a fluke of a once in a universe lifetime. And the other question was, has there been any life form other than the DNA RNA code? No. What is that code? Well, it's technically a quasi-crystal, which is a geometric code or language, right? It also has the same symmetry as the quasi-crystals we work with. It's called H, right? H2 symmetry is 5-fold symmetry. Each of the two helices has perfect five-fold symmetry. And it's based very much on the golden ratio, right? Like the two strands are offset by one another by two Fibonacci numbers, and Fibonacci numbers approximate the golden ratio. Long story short, that's the second piece of evidence. It has only happened once, and if it ever tried to happen again on some other planet, it would usually get snuffed out, like the way those mutated cubs were that were 20% smarter. But we've somehow done a Leonardo DiCaprio Catch Me If You Can, because evolutionary biology hasn't been able to snuff us out yet. We haven't done the nuclear war. We haven't finished polluting our environment yet. We're still trucking away.
But then I think what you're going towards is this idea that us from the future is actively making changes to make sure that we don't snuff ourselves out, right?
I'm going to get there because that would be in their self-interest, wouldn't it?
Yeah, very much
So,
so.
so long story short, there may be a logical concept where beings from our descendant tree forward in time could have moved around in time and made physical changes. You don't have to have a physical body to make physical changes. What you have to do is observe. In other words, with your mind, if you can observe a physical system, you fundamentally change the behavior of that system just by your knowledge of it. It's already been ruled out that it's photons exchanging by the opposite. No, it seems clear that observation changes the behavior of a physical system. So if you can observe in a very strategic way, in principle, you could do things like change the system such that you rewrite the genetic code. Now, if you're from the future and you want to genetically modify some primate, like some kind of ape that already has a nice brain to body mass ratio, but you wanted to jack in, like you wanted to manipulate it to get it to have this weird prefrontal cortex, maybe a psychic ability, maybe the Egyptians were right, and maybe the pineal gland could have something to do with access to non-local information, maybe. But if you gamed it like that, with this idea of retro causality that we talked about, then fine. So back to the evidences. So we've looked around in every direction of space, every distance in time, and it's as quiet as a pin drops, as though we're the first high consciousness life. For a quasi-crystal structure like DNA to form, this is what Carl Sagan and the other guys missed. Having undersea thermal vents where we see life, living. I'm sorry, but that's a naive, incomplete picture. The fact is, it doesn't spontaneously emerge. It comes because there are already seeds of single-celled life forms all around that water, and those single-celled life forms are descendants of some OG single-celled organism that was the very first. And why the hell did that very first one happen? And what are the odds? Then you can ask, what are the quantum mechanical odds that some atoms will spontaneously self-organize into DNA? And there has been a calculation done on this. And the probability in quantum mechanics of that happening is like 10 to a number that has 4 digits. In other
Yeah.
words, approximately impossible. And yet it happened, right? So it is naive to think that just because a planet has water, and many of them do, in fact, probably 50% of all stars have a Goldilocks distant planet with water, liquid water, right? Now, that does not mean that this complicated language called DNA will just self-organize. And as far as we know, all 100 million of these animals on Earth, over 1/3 the age of the universe, 4+ billion years, have all been based on that same code, the RNA DNA structure. So it may not be very likely at all that life emerges, and even if this DNA emerges or other forms can emerge, and if other forms can emerge, why out of 100 million species has there not been a competing molecule of life that encodes a genome? Why just this one? So long story short is even if other molecules could encode it, or even if DNA somehow happens against all odds on all these planets with water, then you got the other problem of the 100 million that are not high consciousness storytellers capable of discovering the very mathematical fabric of reality and ending up emerging into a collective consciousness that can become the substrate. So there's that. Another piece of evidence is that these things are reported to be hominids. What the hell is up with that? With all the variety of life forms, these things are upright things they're apes. I'm sorry, but you look at any of those alien things, they're apes like we are.
And that's one of the things that has always troubled me is they are so similar to us, right? Physiologically. I mean, it's the bilateral symmetry, the head, the mouth, the nose, the, vestigial ears. I mean, all of
upright. I
those.
mean, how many animals do you see walking around upright like us? And so so then we get to the idea that's a weaker piece of evidence. Those are strong, chunky little morsels there. Let me give you a kind of weak piece of evidence. Why are you guys watching us? Why are you talking to us? Are we like somehow your ancestors? Like, are we family? Like, what the hell? What's your interest in us? What's the big deal? Right? That's weak. But you can throw it on the Barbie, right? You can put that with the others. The other thing I want to say is a fact, okay? Elon Musk is like me. He hopes that we get off planet before we blow ourselves up or extinct ourselves. Once we get off planet, not to visit, but to colonize, it's like the genie of high consciousness, technological consciousness, has escaped. And it just keeps propagating out, and you can never get it back in the bottle. It's contaminated the universe permanently. Okay, I think it looks probably like we're going to get off planet, and I hope that we don't, blow ourselves up here back on Earth. And so think about how 100 million species, as different as they are from one another, are all descendants of the same ancestor, the original arrangement of DNA in the mother single-celled organism 4 billion years ago.
Yeah.
Similarly, start us off. Let's do that same thing. And we say, well, let's start us off as that multi-celled organism, the genie that gets out of the bottle, starts populating the universe. What happens? Well, two things happen. One is your descendants speciate. They become different species, just like what happened.
Yeah, and that's one of yes, I have definitely felt that will happen in the future. Again, this blurring of natural and artificial. NASA has talked about like genetic modification for different planets, different environments, right? Another thing, if you're talking about some kind of time travel, maybe our descendants speciate over time. And so, these creatures could be like from 50,000, 500,000, 500 million years in the future. They would look very different, right?
Thank you, Tim. That's teased me up to give a visual. So think about a graph that's like a tree, a fractal tree. We're going out and up. So we start with the single-celled mother organism 4 billion years ago. And then when we go up, it's the time axis. So as we go up, we only have 2 or 3 just shortly after her. It speciates completely different species, but still her descendants. And then as it goes further up, it branches out and you get more and more and more species. We're up to 100 million so far. So we take that with us and we say, well, we're going to get off planet soon, and our descendants will move out to different locations of space and time as time goes on. And the quantity of species, just like in this one that happened on Earth, will fractally explode, such that eventually there will be more descendant species, different species, that come from us as the germ origin than the 100 million that came eventually. They will be everywhere. But the freaky thing is this: because they are all descendants, they will carry with them always anything scientific that is true, right? Like, there are some science theories that will turn out to be not true and be replaced, but there are some fundamental things, especially in mathematics, right? Like with mathematics, it's more like pure, there's less conjecture. So they will carry this knowledge of math. Now, hypothetically, if I do my mission correctly, we will discover humanity circa 2026, 2025. Let's say humanity discovers the first actual first principles unification of the theory of time and space and the theory of particles. And maybe it's something like cycle clock theory, hypothetically. Now, if that makes predictions and it's a very true theory, then all of these descendants that are not human and not born on terra firma, like, you can't get any more alien than a non-human not born on Earth, right? And yet 99.999999% of our descendants smeared across time and distance will eventually be just that: non-human, not born on Earth. They should be called aliens. But you also would have to say that they would also be called family, our descendants.
Yes, and I firmly believe that. I think that humanity will, like you've been saying, it will smear out and blur across a large variety of forms and factors, and again, natural and artificial. I think that those words will lose their distinction over time, but they will be part of humanity.
And let's presume that, about how many people do you figure will watch this video after a couple months?
Well, I will put a timeline in this because we're going over a lot of different concepts.
So let's say a few thousand people are going to watch this eventually. And if a couple thousand people watch this, there's certainly going to be at least one comment who points out the obvious: how arrogant it is for Klee Irwin to think that humanity would be the first high consciousness form of life in the universe. And maybe it is arrogant, although I'm trying to come to it in a non-political way, like not caring what people think of me about being arrogant, but to really deduce and just say, well, everything is a probability. I'm only guessing. That's all science is. And this is where it leads me. But here's the cool joke. If we're not the first, then somebody is the first, because there's always a first. No two things happen at the exact Planck time moment, right? So whoever is the first, they are going to be, by definition, a high consciousness kind of beings. And some arrogant asshole will say, hey, I think we're the first. And then the other high consciousness ones are going to say, you arrogant bastard, how dare you? And arrogant or not, by definition of how I'm setting up the statement, they were the first. Okay, so it could be us. The evidence points that it's us. Now, someone may say, well, what about evidence of, these aliens in the past? Okay, absolutely. If we discover the keys to the kingdom, the first principles theory of everything, perhaps it will allow us to move consciousness around in time and to influence matter, all the way up to remolecularizing things, creating life forms in which we could inhabit as avatars. Let's say that nothing is off the table if it's not prevented by a physical theory that is absolutely true. If it's not prevented, then that which is possible given enough time eventually occurs. And so what would happen in this kind of scenario is our descendants forward in time begin to just colonize places in the past.
Yeah.
right? And now now everything's mishmashed, mixed up, and it gets confusing, right? Like,
Well,
wait, you're from the future, but then you went back into the past on some interesting planet or some whatever, and now your descendants there are born in that past, but you as the parent, you actually came from a location in time in the future. So it
and
all gets mishmashed.
yeah, so I did an interview a couple of years ago with Dr. Julia Mossbridge, and she said something that stuck with me. And she said, when you're talking about the vast expanses of time and space that are involved with things like this, it loses its meaning, right? And so,
Yeah.
again, when we think future and past, for us, we're tending to think within like lifespans or generations. But if you go, hundreds of millions of years into the past, it's effectively a different world.
Tim, Julie, she invited me to a conference she organized maybe 2 years ago at the University of San Diego, UC San Diego. Anyway, I went there, I did a presentation. I have a pretty cool PowerPoint, and if you wanted to post that, you got to remind me and get it off me by email. But there's a neat PowerPoint that has some visuals that are along the lines of what we've talked about earlier. Um, but yeah, that was a conference for physicists about time travel. So yeah, so I think that's my evidence pieces. Hominids, we've listened to the sky. But remember, when we've listened, where did we listen? Always in the past. Even Alpha Centauri is the closest star. That's 4 light years away. It's an ungodly distance because it's hard to imagine how fast light moves. Now, if light moves for an entire 4 years, that is a long ways away. Most of the targets where they listened were things far further into the past. In other words, when you look at Alpha Centauri, you're looking at the past 4 years ago. When you look at our star, it's 10 minutes ago. But when you look at most stars, like the stars of another galaxy, it is a long time in the ancient
Yeah.
past. That's where we looked. We didn't look into the future because we don't have the technology to look into the future. So looking into the past revealed nothing. Quiet as a pin can drop and you hear it. So anyway, so all of these little circumstantial evidences from the sample size of 1 out of 100 million to the hominid form to why are all you guys so interested in us, right? I think I think it makes if I look, it's fantastical as an idea, but that's the thing about extreme questions like the Big Bang. I mean, that's a freaking wait, so an infinitely small energy explodes and becomes everything. Like these are fantastical ideas. And you got to pick the lesser of evils. I think that the lesser of evils, if we're just trying to place office bets, is probably these hominid looking things are us, our descendants, us from the future, if you will, but not human.
Well, and this goes to so many big things. A lot of what you've been saying reminds me of a book that I fell in love with called The Light of Other Days. It was Arthur C. Clarke and Stephen Baxter. And they had this idea, it started with this idea of a wormhole cam, right? Where you could capture just a few photons through a wormhole, nano wormhole. And then they went from there to saying, okay, you can move that back and forward in time as well as space. So you can see the future and the past, like you've said. So you've got information there. And then towards the end of it, they started to talk about, well, you can move a little bit of energy through it too. And so for something like that, then you could 3D print your explorers in the past, right? One atom at a time. So
You bet, Tim.
yeah, so that enables time travel right there.
Well, it's funny because there's two pillars of of fundamental physics, quantum mechanics, general relativity. General relativity, right in the equation, says if you could make a wormhole that is traversable for a human, the human could walk right back and forth between the future and past. Let's say it's a wormhole set up to you and your family 1 year from now. So you walk in and you're like, hey guys, guess what? Tim Ventura, back from 2025, he says this, he did that. And then you say, you have anything you want me to tell Tim? And they're like, yeah, tell Tim we're still watching his podcast 1 year later. So they walk back, and Tim's like, "Oh my God, that's great!" And it changes Tim, and then it changes them, and
Yeah.
you can slap them, you can bring them a rock, you can do these things. That is allowed in the Einstein field equations. So let's go to quantum mechanics. Let's say that because we've proven with experiments that we can entangle uh, two particles across time such that they act as though they're two sides of the same coin. There's no the change that in the way that they influence one another. It's not happening with a carrier signal like a photon that moves at light. It's more like an instant thing. So let's move that to the upper limit and say, all right, so let's say that whatever Tim Ventura's consciousness is emerges from a bunch of quantum entanglement off-on switches, just a bunch of quantum biology in his skull, right? And then Timness emerges. All right, so we say that. So then we say, all right, well, let's take his skull tomorrow, right, or in 1 year, and let's somehow just make this in principle the thought experiment. So what if the entanglement entropy is the magnitude of entanglement, right, between a bunch of particles? So let's say that the entanglement entropy is such that we've somehow wired up the two Tim Ventura brains in such a way where the emergent consciousness of one and the other somehow exchanges this ineffable abstraction, right? Now, we have something in quantum mechanics called the no communication theorem. And what that
Yeah.
means is that you can't use that, what I just said, to cheat the system and access what we call quantum state variable information. That would include things like spin up, spin down. You can't, in the no communication theorem, and I'm not saying it's a true theorem, but I'm saying if I pretend that it's true, does it obliterate this thought experiment with the two Tim Venturas? No, it doesn't. It prohibits quantum state variable information to be cheated like that across time. But Tim traffics in irony and humor, right? And abstractions that are not mathematically definable. They are far from quantum state variable things like spin up down. So we're saying that we know that all the particles here are changing the ones here. That's the nature of entanglement, right? You measure the spin here to be up, and now you know by fact that the one in the future that it's entangled with is spin down. So it's as though your measurement collapsed something, made it, change the probability spread, and then it changes, right, the physics up there in the future. So if we admit that we don't know this black box of Tim Ventura, but we know that it has something to do with quantum biology, and in principle, if we could get the entanglement entropy to have such a high magnitude between the two Tim brains separated in time by 1 year, that we could get them in principle to exchange this emergent abstraction of irony or thought or qualia, the color blue, whatever. So that is really a neat way to show that both general relativity and quantum mechanics have no deal killer.
Yeah. Yeah. That makes so much sense. That makes so much sense. So yeah, I think we have run through so much stuff. I'm trying to think of if we've missed anything. So one thing I did want to ask, this is kind of out there, but lately I've been hearing a lot more about orbs versus UFOs, right? And
Yeah.
I think that's very interesting. One of the things I'd wondered is, are these orbs some kind of a communications or listening or watching device, as opposed to these UAP, UFOs, which appear to be vehicles,
So the vehicles themselves are known to phase in and out of solidity, right? So they'll look solid and then they phase shift and they become ephemeral, right?
Yeah.
That's some of the reportings, okay? And then you have the orb type things that stay plasma-like or ephemeral-like, okay? So let's check one box and realize that the zoo of our descendants in this fractal tree spread across both time and distance has perhaps as much variety as the 100 million species
Okay.
behind us, okay? And now that means that you're going to have all different forms of consciousness. You can have consciousnesses in our descendant tree that don't require atomic structure. They're based in gravity waves, in light, in EM, or in some sub-quantum gravity picture that we have not discovered yet, such as what we do. The point is that they would come in all different flavors, but the one thing they would have in common is let's get some alien popcorn and watch what is happening, as though what is happening with humanity right about now is somehow about to go into some phase transition, as though this is a historically important time. Because if you go back to like the 1970s, there was, a lot of us believe, there's an accelerating frequency of these sightings, these events. Now you could say, oh, it was suppressed and you didn't know, and it's just the exact same. Okay, but that's a theory. I have a theory that their observations and interactions are increasing lately. That's my belief.
Yeah.
So if it is, perhaps it's because we're heading into some phase transition, if you will. Maybe the phase transition has something to do with the important fact that for the first time on this planet in 1/3 the age of the universe, a neural network more creative and more intelligent than Homo sapien has emerged. I'm
Yeah.
sorry, but the creativity of the films, the poems, the images, it's freaking heart moving. And the intelligence, these things are coming up with math theorems. It's creative, and we've only seen the tip of the iceberg. That's an X factor that is non-trivial. Whatever happens with the evolution of humanity in this regard is about to happen so fast that it will be the single most violent disruption to hit humanity that makes the printing press, the discovery of the computer, the internet, and fire look, and the discovery of even quantum mechanics look like child's play.
Well, and that was one of the things. There are a couple of different folks. I did an interview with Gennady Stolyarev, right, with the Transhumanist Party, but he is a tremendous singularitarian. And one of the things he had suggested was that what we view as the singularity may be more like an S curve with a phase change, like you
Yeah.
said. And he'd said, these happen in the past. Fire might be one example of these, right?
Yeah.
Where, before fire and after fire, completely different. You could not visualize what the world would be like after the fact. So if we go through the singularity, we hit AGI, we will be in a very different world. And yeah, our descendants would probably have a great interest in at least documenting and seeing what's going on, as well as ensuring that this happens, right? You would think that they would want to make sure that we make it to that point.
Good point. And the way that I would do it, if I were them, is I would discover some effective form of non-local communication such that I could whisper in the subconscious minds of dreaming humans intuitions about seminal mathematical, physical, computational theory ideas. So if that is possible, to move the consciousness to another location and then influence physical and mental systems in those other locations, then they should do that for logical reasons. I think that ASI will be here very soon. Sam Altman, Ilya Sutskever, all the big guys are agreeing with that, Elon Musk. And that's because once you hit AGI, when computers can do everything as good as we can do, then that means they can do the V2.0, 3.0 upgrades as good as
Yes.
we can. But the difference is they do that at a significant fraction of the speed of light, and we do it exponentially slower. That's why we take a long time to do version 2.n, right?
Well, And this, I think this goes back to your idea of first principles, as well as this older new kind of science idea of fractal stuff. But if you can calculate, right, using future quantum computers, you can take advantage of the butterfly effect, right, where you could make a little nudge in the past to accomplish a desired result that wouldn't make any sense to us. And like you talked about implanting, ideas and hopes and dreams and things like that. And who knows, maybe it would be a concrete physical thing, like you bump a rock over here, but
That's
you have
right.
the calculating ability to know that bumping that rock, right, might make a person trip, and then they would have that idea that would lead to that big thing. So,
One of the things that you can bump a lot easier than a rock, if you're open to the science and the peer review stuff on psi phenomena, right? One of the categories of psi phenomena is how the mind can influence matter. Like my friend Dean Radin has hardcore peer review stuff that shows experimentally that the mind influences the double slit experiment.
yeah, the Global Consciousness Project. Yeah, I'm a big fan of GCP, which is inter. Yet the impression that I get is that human consciousness somehow influences quantum randomness.
Now, what would be the most strategic thing and easiest thing in the regime? So that's what we call telekinesis. So when a mind can non-locally influence the double slit experiment, like in Dean Radin from Ions, his experiments are hardcore slam dunk. You'd have to accuse him of being a liar on purpose. But if you don't accuse him of being a liar, then the sigma, right, the compellingness of the data is slam dunk, mic drop. The human
Yeah,
mind is influenced matter, and that's telekinesis. So a form of telekinesis would be to mod the code of DNA. That would be a lot easier than moving a pencil across a table, okay, in terms of mind over matter telekinesis. And why would you want to do that? Well, where do you think your ability for this supposed psychic non-local access to information, influence of stuff, where does that come from? Where does your consciousness capacity as a Homo sapien come from? Well, obviously, it's just the way that the four letters are arranged, right? Arrange them a different way, and you can become absolutely stupid or much, much smarter, maybe more psychic. So I think that there's no good reason why they would not have modified the DNA in order to potentiate. And for that matter, what if there were some reason to keep humans not so psychic and not and dumb, or to have people have a propensity to be followers or sheep?
well,
That
so
you could
then
modify it that way too.
now, do you think that this might explain abductions, or do you think that's a psychological phenomenon more than a physical
Yeah,
concrete?
I personally don't get too much into the UFO phenomenon and community uh, because, well, because this first principles thing, the keys to the kingdom, is far, far more important, and
Yeah.
and because the self-simulation hypothesis paper in the cosmology, it actually requires countless billions of speciated descendants across time. It's so freaking variety that it's a zoo. I mean, look, you just take one species, humans, and you look at the variety of behaviors from selfishness to weirdness to weird cults and science, and you take it all. Now you take countless trillions of species that all carry very high consciousness and knowledge of the facts of science that are the true things, like in math, that don't get replaced. And you're going to have all kinds of motivations. The thing is they're not all going to be nice, right?
Mm.
They're not like we can
Well, they would be
we,
like us. Yeah.
well, they're going to be more pure than us. So if they go into a free will decision to use their knowledge, their power of manipulating reality and understanding it, if they're going to use that to be of service to themselves in any way, like I'm going to leave that as very broad, then that's a thing. Go for it. Free will. Other one, and they can become very pure in that. they can also, others will go purebred service to others, and you can leave that broad as what that means. And they're pure in it. Humans are not pure. We're all over the place with
Yeah.
selfishness and unselfishness. Even Hitler was probably kind and unselfish by handing, some his food to a kid, his nephew or something, right? Like, so I think that we have to be careful to say that knowledge leads to kindness, right? Or
Mm,
unselfishness. It doesn't. Knowledge leads to knowledge. Knowledge is power, and you
yeah.
can use that for selfishness or unselfishness. So if we say that some double-digit percentage of our descendants are in this flavor that I call pure play service to self, right? And others are pure play service to others. And then we also allow phases of consciousness. Like think of a hyperdimensional consciousness, but the thing about hyperdimensional math is you can have different ranks or complexities of hyperdimensionality, like more dimensions, if you will. So I think we got something like that, and I think that these abductions um, probably relate to maybe a little bit more of the service to self flavor of our vast speciated descendant network, um, or there's another reason. But in a way, I don't care too much about it. It's just like I don't have time to care about all the social
Y-
groups, social motivations, constructs with my own species here. And so I just accept that. To me, it's like everyone, like, unless you think somehow that our descendants don't exist and you don't agree with special relativity and the fact that we received the hard, cold shower in 1905, that the future, past, and present all exist with equal realism. Like we didn't know that before 1905 and Einstein's paper. It was reasonable to think that obviously the past doesn't exist anymore. And obviously, the future doesn't exist anymore. The only thing that exists is this moment. That was rational thinking. It just turned out that, it was incorrect.
Yeah. Well, that is so much. So, Klee, I think we should probably wrap things up
Yeah.
today. But let me thank you again so much for your time. It's truly a pleasure and absolutely an honor to speak with you. And
Thank
we
you,
will
Tim.
have to come back if you're open to it. We will do more of these in the future. So,
Yeah, it's fun, Tim. I would I'll receive your beck and call anytime you want.
okay. Well, thank you again. And I'll close things down for today, sir.
Awesome.